Dear student, welcome to the fifth lecture of CS710, Mobile and Pervasive Computing. To bring you up to the speed what we have been talking about, we were talking about how pervasive computing came into being and what are the composition of pervasive computing. We saw how exciting concepts from distributed computing and mobile computing were brought together and used innovatively in pervasive computing. Distributed computing contributed a lot of concepts like fault tolerance, high availability, remote communication, and mobile communication or mobile computing also introduced many concepts such as mobile networking. These concepts are bring together in pervasive computing to make it flourish, make it grow, or open new research avenues in it. To give you an example how the things moved, consider the concept of information sharing. Information sharing the idea is simple that you want to share information among your peers, among your friends, among different computers. In distributed computing, we named it as distributed information sharing. Distributed information sharing the idea came as how the file system would be distributed among different machines. The idea came as how databases can be distributed, how caching can be applied so that the speed of information access would be better. Then we moved on to the domain of mobile computing, and mobile computing took this idea of information sharing to a new domain, to a new level. They called it mobile information sharing, and the idea that were introduced in this domain were disconnected operations. That what will happen if we are not connected to those servers where our databases are or where our file systems are. And then the idea of weak consistencies were introduced. Beforehand, we were working with idea of consistency alone. Consistency means that the information that is available to the whole enterprise or a group of users is same wherever you will access them. But when mobile elements came in, there were problems because sometimes you don't have connectivity and therefore you cannot update records, and then you have a different set of information than the whole other organization. Therefore, the idea of weak consistencies were introduced. That is, that it is okay if some of the components in the enterprise would have the latest copy, and from there the information is distributed or weak or strong consistencies is achieved. We will come to the idea of consistency and how information sharing is done. But the idea behind revising this concept at this moment was to give you an idea that given a simple concept like information sharing, we have come a long way. We keep on adding things to that, and then we have come at this point. It wasn't just that we added the ideas from different domains in mobile and pervasive computing. It was also that mobile and pervasive computing brought its own set of ideas into action too. Some of the ideas that we discussed last time was use of smart space. Now, the pervasive computing went beyond the idea of indoor or outdoor access. We talked about how the spaces were transformed into smart spaces by bringing together two distinct ideas. And the ideas were physical infrastructure and computational infrastructure. Just like when planning a building, we think about how electricity will work, we think about how water supply would work, we also think about how computational elements or communicational elements will be placed inside the building. This is where the concept of smart spaces comes in. When we talked about smart spaces, we also talked about how to utilize them. And we quoted the example of Aware Home. That was one earlier research project that used the idea of smart spaces for different purposes. The purpose was to help users live inside the building. The users can be very capable or may have disabilities. To help research community understand how human beings live by collecting ideas or collecting data on how electricity is used, how water is used, and so on. So this is the utilization of smart space, how we can effectively utilize smart spaces. Second idea that pervasive computing brought in, that was invisibility. That is, it wasn't that it should disappear altogether, but the idea is that it should be made so common and the technology should continue working according to the user's expectations and present him with little or no surprises so that he wouldn't notice the technology. The example I quoted last time was that when you have sensors embedded inside your floor, inside the ceiling, just to track the movement of user. And the idea is that when the user moves from one place to another, as he approaches the door will open automatically. There are sensors there that detect that, okay, user is moving this in this direction. And when he moves and reaches that point where he is facing the door should open automatically. In this perspective, if the door doesn't open, you are not performing according to users' expectations. Think about this, that every day you pass through a door that opens for you automatically. After some point, you stop even noticing it, that okay, door is opening automatically, and you stop thinking about the technology that is going behind. For you, it's just a movement, you move towards the door and door opens. It's as simple as this. But one day, for some reason, if the sensor malfunctions, then you notice that you approached the door and the door didn't open. What does that mean? That means that you have to indulge yourself into the technology. Now you have to look into all the sensors to make sure that they are working fine. You have to indulge into the technology that is opening the door and see if that is working fine. So now the technology has gone beyond your consciousness. Before it was sitting in your consciousness, but now in your from your subconscious it came up, and now you have to worry about it because it didn't perform the way you wanted. A related concept in this is the idea of scalability. And we discussed it like this, that when you make a smart space that is so clustered with computational and communication elements, you have to take into account how communications will happen or how the load management will be done. Think about this, that if you have installed sensors in a smart space to measure or to detect the gesture of a person, that how he is moving his hand, the way he is moving his legs, the way he is moving his head, all these things. And there are a number of sensors that are installed just to measure it. Of course, it is of no use if the sensor will keep this data to themselves. Moving of head may not mean anything unless it is combined with some other gesture. Maybe moving of hand wouldn't mean anything unless you will relate it to the moving of feet and detect that you have reached the door. In this perspective, when all these sensors will communicate to a central authority to tell them what they have detected, it might cause a congestion at the communication point. There are two implications of congestion. First of all, the communication element who will be moving data across servers and across the sensors will deplete very soon. By depletion, I mean the energy source of that particular element may deplete very soon. And if it's not, that is assuming it's on mobile battery. Second implication, and that is the bigger one, is that consider that you are doing real-time operations. And by real-time, I mean that you move to a door and door should open at that particular instance so that the user won't know the difference that there is a delay. Or if you go and sit in front of a TV, it should detect that you are sitting in front of a TV and TV should turn on. When the congestion happens, the data streams will get delayed. As the data streams will get delayed, now the real-time action might incur some delay. As the delay will incur, the user will start noticing things. And as the user will start noticing things, again, the same effect will happen, that the technology from the subconsciousness has now come into the very conscious of human being, and they start finding out what is the reason. Another related concept that we discussed last time was that smartness of various environments vary. And we termed it as masking uneven conditions. And the reason is this, that the smartness of various environment, whether built on purpose or whether installed afterwards, vary. आप लाइब्रेरी में जब जाते हो, तो maybe you will get a very good Wi-Fi coverage and everything is there, and you can connect from wherever spot you want, but there are few spots where you might get little or no connectivity because there are shelves, there are books, there are barriers which might hamper the connectivity or the radio signals. When you go outside, there is no such barriers, no such walls, anything. It's open field, you sit anywhere, you get the signal, but not all the places. Just around the university, and as soon as you go from ground A to ground B, you might stop getting the signals. There, you still have a connectivity option, maybe GSM, but the speed difference between both is huge. One is talking Mbps, and that also 50 plus Mbps. That is our Wi-Fi. Second is talking kbps, and that's simply 114 kbps. That is GSM. So immediately you will notice the difference of connectivity. The web page you are trying to load there would get loaded so very soon, but in GSM you will have to wait. These are uneven conditions. Both environments are smart. By smartness, I am simply implying that if I get connectivity, I would assume that they are smart. But the smartness of these environments are different. In one environment, you are getting a very good bandwidth. In second environment, you are getting very low bandwidth. How to mask this difference between the two environments is yet another goal or idea behind pervasive computing. Today, we will continue talking about the composition of pervasive systems, and we will go beyond the idea of mobile or distributed systems. These are two very important concepts. Okay, good. We understand that distributed computing started the whole wave in 70s. Then we moved on to the mobile computing domain. This is the idea that was flourishing in 1990s. And from 1990s onward, we are talking about mobile computing and pervasive computing together. So the term coined by IBM was, again, mobile and pervasive computing. Very good. These two are very important domains and contributed a lot to mobile and pervasive computing. But what else? What are the other domains that contributed directly or indirectly towards the domain of pervasive computing? And let me start with the idea of context-aware computing. If you remember, we discussed this idea in mobile computing that context awareness is something that lets your device or lets the end user application act accordingly the environment it is operating on. So when you bring it context awareness, and imminently you will talk about sensors. That, okay, there is a sensor that will locate your location, there is a sensor that will locate how you are moving, there is a sensor that will do this, sensor that will do this. Sensing or sensors is a very important technology that was developed in context of context-aware computing. Another important invention that happens along the same lines was actuators. Sensors and actuators are two hardware components that can act either alone or can be embedded in some devices, and the functioning of both are complementing. Sensor detects and collects data, whereas actuators are supposed to perform some action. An example is that sensors collect data that user is approaching the door, and actuator will open the door for you. This idea has been used very effectively in robotics. Very sophisticated sensors and actuators are being used. Then this idea is also applied in cars. Nowadays, some high-end cars are equipped with sensors and actuators, and the way they work is that when distance between two cars is less than a given threshold, they will alert the user or the driver by sounding an alarm or applying the brakes automatically. Or if you are reversing and you are close to a wall or some other object, again the sensors will tell the actuator to engage the brakes. So this is where the sensors and actuators comes in. When we talked about sensors, another important concept that came was networking. We already talked about how mobile networking works. But in context of sensors, or even in mobile networking, there is another dimension that we haven't touched yet. And this is probably right time to discuss that aspect too. When you think about sensors, sensors are built with a purpose in mind. And the purpose is that they should be self-sufficient, autonomous entities that are able to communicate and collect data for you. So to make them self-sufficient and autonomous, we gave them battery power. We gave them some of the connectivity. And what we did was that we built so many of them and we just throw them. This was the original idea behind sensors, that you will have so many of them and they will be so cheap and they will be so small that if you want to collect data from some environment, you will just throw it there and they will be so self-sufficient that they will keep on collecting data and they will be sending them back to you. Some of the environments that sensors used, we already talked about Aware Home, but this is a planned environment. Some of the unplanned environment are natural habitats like Amazon jungle, like deserts, and even in the enemy lines where you want to detect some information, you will just throw these elements, and they are so abundant that you will hope that some of them will eventually work, and they will collect some data and send it back to you. The dilemma here is this, that sensors can collect data and they can communicate, but their communication range is very small. So what we do now? There came the idea or the concept of ad hoc networking. The idea of ad hoc networking is that what about a communication network that doesn't require any infrastructure? By infrastructure, we mean that it doesn't require any wires. By infrastructure, we mean that it doesn't require any IP addressing, predefined IP addressing, I would say, and it will be formed dynamically, so that whenever 2 or 3 computers comes together, without any pre-planning, they should be able to communicate with each other and exchange data. This was the idea that came with ad hoc networking. This idea was later refined, and now you can even use it in Microsoft Windows. In Windows, it gives you ability to perform an ad hoc network with any other computer if you want to, and exchange information. One of the major use that comes with ad hoc networking is this. Consider that I have a Wi-Fi spot somewhere, and I am in the range of, my computer is in the range of that Wi-Fi spot. That Wi-Fi spot covers around 10 meters, just for example's sake. It covers 10 meters, and I am sitting in that 10-meter range. I am just at the boundary of 10 meters, so I am sitting at 9 meters or 10 meters per se. My computer can detect or send signal for another 5 meters. So there is a circle. If you put an imaginary circle around my computer and Wi-Fi, there would be a circle in which Wi-Fi is sitting, and that is covering 10 meters in the round circle. Then on the edge of that circle, there would be my computer, and there would be another circle for my computer's connectivity, and that is covering another 5 meters. There is a computer that is sitting in the 15 meters range, and that wants to connect with the Wi-Fi to access internet. How would that happen? It can't access Wi-Fi directly, but it can go through me because that computer is in range of my computer and I am in range of Wi-Fi. So what will happen is that I will form an ad hoc network in which I will allow other computers to connect to me, and I will relay all the information to Wi-Fi, and that Wi-Fi will in turn give them connectivity to the internet. So this is how usually ad hoc networks work. But this is only the scenario where I need the internet connectivity, so I need to connect to a Wi-Fi. If the idea is just to exchange information between the elements that are sitting there, that can also happen through the ad hoc network. And just like distributed computing, the restriction is not that there should be one more computer. There can be as many more computers as you may want. But the restriction here is the scalability. Of course, when instead of one computer, I will have to deal with hundreds of them, I will start feeling congestion. My communication channel will choke, and I would not be able to handle the communication gracefully. Because 100 computers will be communicating from one side, and then Wi-Fi will be communicating the data for these 100 elements on the other side. I might choke very soon. So scalability is an important concept that comes here. Along with sensors and actuators, there is another important concept that get evolved in parallel to pervasive computing and played a very important role in pervasive computing, and that is operating systems. Operating systems got developed in context of pervasive computing because, first of all, the size of operating system. When you look at traditional operating system, now it is occupying spaces in GBs. Some are 10 GBs, 5 GBs. Depending on the operating systems and the utilities you install over it, it takes a lot of space. And when talking about mobile computing, we said that mobile elements put a restriction because of their weight and because of their size. So we might not have that much storage available with us. So that caused operating systems to trim down a bit. Second, the functionalities. Operating systems are made generic, so they come loaded with a lot of functionalities. Assuming that they will have to cover a variety of graphic cards, they will have to support a variety of network cards, assuming that they will have to interact with number of other peripheral devices. They are loaded with all kind of information that the end user may or may not need. The idea is that make it so generic that everybody who installs that operating system, it will fulfill his needs. In mobile environment, it is a bit different. And Most of the functionalities are additional, but some of the required functionalities may lack, such as in laptop or desktop world, GPS is not very common. So not many of the operating systems came loaded with GPS functionality. Whereas in mobile environment or cell phone environment, if you think of, we use GPS very frequently. Or GPS is an essential feature in all of the smartphones or high-end cell phones. So operating systems need to be modified. Other aspects that operating systems needed to consider was energy management or power efficiency. This is a very hot area nowadays with power crisis going all over the world. Not only laptop computers or mobile computers, even desktop computers have started thinking about how to conserve energy. And we talked about before that yes, there exist techniques that reduces the power of individual elements, like power stepping that is available in processors. There is power efficient graphic cards, there is power efficient storage available, but to orchestrate the working of them together, operating system plays a very important role. So the end authority lies with operating system, that it will decide how to use the hardware and how to use them power efficiently. This was the idea that came with pervasive computing, that when you are running on mobile power sources or limited power sources, you will have to consider the power efficiency. Another thing that mobile operating system needed to consider was application adaptation. Now the applications, just like in laptop or desktop world, when you take one application from the other one, you will have to consider the interoperability. Similarly, in mobile domain, you will have to consider the same, but problem here is a bit bigger, and we will talk about it. Just to give a summary of it, mobile devices are so much more than the laptops. If you remember the graph that we showed last 2-3 lectures back, mobile devices or smartphones per se were predicted to sell around 400 million, whereas laptops were around 200 million, if I remember my figures correctly. So this is another important concept that we had to consider, that what if an application will move from one environment to another? How will we handle it? Another important concept in operating system was disconnected operations. How will we handle when connectivity is either low or is not available at all? What will operating system do? How will operating system will facilitate the operations so that the end user would not notice any considerable difference between what is happening in the application? This was an important concept that, again, operating system played a very important role. Another important concept that was developed in conjunction with pervasive computing and contributed a lot towards pervasive computing was computer architecture. If you remember, we talked about variable computing. The idea was that make computational elements so small, or the devices so small, that we can use it every day and along with the things that we usually wear. This idea bring a new revolution in computer architecture. People thought about innovative ways of how to shrink the hardware and how to use minimal power sources. This was the idea, this was the domain that helped pervasive computing progress, because again the idea of pervasive computing was the same, that we should be able to make or to integrate the hardware in our daily lives very easily. Other concepts that were developed in pervasive computing's domain were software engineering. And software engineering will be a very vast subject that we will be using for or discussing for the rest of our course. But just to give you an idea, what are the important aspects in software engineering? First of all, our traditional software development models weren't as good as they were thought they would be. And I will refer back to the ideas that we discussed a few lectures back, that the technical challenges that were faced by mobile or pervasive computing were of three kinds. The first kind was those problems that were faced before, there were solutions that existed, and those solutions get ported as is into mobile and pervasive domain. Second category of technical challenges were those that the problems existed before, there were solutions, but the solutions weren't readily ported to the mobile and pervasive computing because of the unique requirements of pervasive environment. So therefore, these solutions were tailored and then made them fit to the pervasive domain. The third kind of problems or technical challenges were those that problems were new, they weren't seen before, and therefore new solutions were sought, new research avenues were open, and then a final solutions were formed. In software engineering, we saw the continuity of the same effect. There were some already existing models for developing software, and we modified them to meet our needs. But some problems were so very new that we have to form new solutions for that. In software engineering, the first biggest challenge for us came from the mobility aspect, that the mobile elements were inherently untrustable. They were not robust, they could fail at any time, and that would create a problem for us. So how would we go about solving this problem? This domain was called self-healing software. That is, when a component fails or a software element fails, what will happen? Then we talked about dynamic reconfiguration. I just told you that operating systems are loaded with bunch of functionality which we might or we may not need. This bunch of, if we load all of them, that will consume our space, storage space, that will consume our battery power, that will use our processor cycles and make it slow. For example, if on a device a GPS is not present and we load the module of GPS, it will probe GPS after every few seconds and see if GPS is working correctly, whereas GPS is not there altogether. That will be consuming our space, our processor cycles will be consumed, and definitely our power will go down. So the idea of dynamic reconfiguration is that software should be configurable on the go. That is, after detecting the resources that are available to operating system or the application, it should be able to reconfigure itself in such a way that it will not employ all the functionality but only use those functionalities that is required and that is supported by the resources available. Then finally came the economic model. And why economic model is important? Think about this. Whenever you develop something, portability is an issue for you. That how come I'm developing it on Windows 7, when it goes on Windows XP, it should work the same way. It should be consistent. I am developing something for Linux, Fedora, when it goes to CentOS, it should be able to handle tasks accordingly. That is, it shouldn't give the end user no surprise. But when talking about mobile devices, and we are talking about 160 million plus mobile devices, and think about it of how many of them would be unique. Let's come up with a number. Let's say 100,000 of them would be unique. So how can we develop for 100,000 devices? In operating systems or desktop world, it's simple. And we will talk about it in later. We will put some numbers and see, compare and contrast that how it weight in front of each other, but the mobile domain is very huge. And when we talk about software development, and when we talk about portability, and when we talk about seamlessness, and when we talk about application portability or application mobility, we think that the application will move from one platform to another and perform the way it is performing without giving any surprises. That also put a major strain on how we will develop an application that is going to run on so many platforms. Moving on from software development, another major concern that mobile and pervasive computing faced was that of security and privacy. And think about it, that if security is a concern in distributed computing, why not in pervasive computing? Now we are talking about mobile elements. We are talking about mobile or wireless information sharing. We are talking about sensitive data being transmitted over the air. When we talk about all these things, immediately our concern is our data safe? Because this data might be very personal in nature or very confidential or sensitive in nature. How can we save this data from eavesdropper, from those people who are listening to it? Because when we are talking about information that is being shared over the air, we are talking the model that most radios work, that the radio stations throw the programs on the air, on the frequency, certain frequencies, and you tune in your radio on that frequency and you get all the information. Similarly, why can't somebody tune in to that frequency where we are sharing information and get all the data? How can we do that? How can we prevent it, that our data is not being shared with anybody else? Let me throw another dimension on the top of private data. Think context awareness. Now I am sharing information that is very personal to me. My location, where I am, what I am doing, what is my environment, who are the people around me, all those things. This is a very sensitive and private data, and I would not want it to be shared with many people. So how can I ensure that this data that I am publishing, this communication stream that I have opened, this information that is flowing from my device to other devices is secure, regardless of channel it is being used? Whether it is wired or it is moving on the wireless channel, it should be secure. So this is another important concept in mobile and pervasive computing, and very important research domain. Let's think about this a bit and think about what is the most easiest way of securing your data. How can we do that? Immediately to my mind, the idea comes is encryption. That is, okay, no problem, we will encrypt the data and then we will send it, so that whoever is listening to that channel or whoever has tuned into that channel wouldn't be able to understand what is in there, and for him it is a garbage, but when on the other side it will be decoded and it will become again meaningful information. The idea sounds very good, very promising, but there is one problem there. And the problem is that encryption is a very processor hungry process. It is mathematical, as you all know, and it takes or consumes lot of processor power when implying a encryption algorithm. Same goes for the decryption algorithm, that it is a very processor hungry process. So when you are talking about mobile elements and you are talking about already depleting sources of power, if you throw in processes like encryption, it will consume a lot of your battery power. So even if we want to go that way, we will have to think about low power encryption mechanisms that can be applied on mobile devices, and still they wouldn't eat much of our battery power. Then in privacy and security, mobile and pervasive computing help us made new avenues or explore new avenues in biometric authentication. That is, now there are techniques that let us scan our fingers, that will let us scan our eyes or voice recognition and perform appropriate actions. These all things comes under the privacy and security model of mobile and pervasive computing. Then we moved on further and we said, okay, all this is good. This is underlying technology. We had talked about how sensors would work, how actuators would work, how we will have privacy and security, how information will flow, how would we encrypt it, how would we develop the software for it. This is underlying technology and very good. But we still haven't talked about the presentation layer of these technologies. Pervasive applications, how will we present it or how will they interact with the end users? This is again a very important area because from laptop or desktop world, the screen size were bigger. In mobile world, the screen sizes started to shrink. Now the elements has to be very small. The screen size are again small and the interactions can be, there are multiple possibilities of interactions. We are defying the traditional model of only keyboard and mice. We are talking about voice recognition, we are talking about touch, we are talking about gesture recognition, we are talking about context-aware input. All these things give the mobile and pervasive domain a new avenues or new research avenues to explore. In the screen, now I am summarizing all these concepts that we have looked into. We talked about operating systems, we talked about distributed computing, we talked about mobile and pervasive computing, we talked about security, we talked about sensors and actuators, we talked about operating systems, we talked about software engineering, and we talked about how the computer-human interaction will be made possible. So in the screen, what we are seeing is a summary of all these important areas or domains that have directly or indirectly contributed to the domain of mobile and pervasive computing. Now that we have talked about all these, that is, we talked about the composition, how mobile computing came into being, how pervasive computing came into being, what are the areas that contributed towards where we stand in mobile and pervasive computing now. Let's move on to a new and equally exciting area, and that is of software development. Till now, we were talking about the physical and compositional aspects of pervasive computing. That is, how the environment will be made, what are the techniques, what are the algorithms that are used, what are the hardware, software components that are used, what are the things that we need to take care of. In essence, what we did was that we formed our environment. That, okay, these are the things, X, Y, A, B, C things that are used in pervasive computing, and we have understood the basic of pervasive computing. So now our basics are there. Let's talk about how we will develop software for this environment. How we will go about creating applications, how we will go about addressing operating system restrictions, how we will go about addressing context awareness. All these things will be discussed in the software development model. And let me start with saying that software development for mobile and pervasive domains is difficult. Or let me put it this way, that developing software for mobile or pervasive domain is different from our traditional models. The difficult part is still there, but we will come to that point, that why it is difficult, why we term it as being difficult. But at the moment, let's just content ourselves by just saying that it is different. Why it is different? Let's think about what defines a mobile and pervasive computing. From whatever we have learned so far, we have talked about so many concepts, we have talked about so many techniques, we have talked about so many ideas. So let's think and let's summarize all these things. And if I ask you to define pervasive computing, not from those concepts that Mark Wazers has done, so I don't want a bookish definition, but I want you to tell me in a very concise manner that what would constitute a pervasive computing. For those people who are seeing me on TV, pause a bit, pause your screen a bit. If you are seeing me on YouTube, just pause it a bit there too, and think of it that if there are two words that would define mobile and pervasive computing, what would that be? To me, these two words come right from the definition. The first one is mobility. That the freedom of mobility that I have given to end user is a very key concept to defining pervasive computing. Everything that I do in pervasive domain from software aspect revolve around this concept. And that second key concept is context awareness. Context awareness, in summary, is ability of the software to adapt itself according to the environment it is operating. The environment constitutes the user who is using it. The environment constitutes the weather conditions that are around. The environment constitutes the application's objective that needs to be achieved. All these things make environment of an application. And a context-aware application is the one who adapts itself successfully according to the environment it is operating on. So these both are very key and important concepts when we are talking about mobile or pervasive computing. Now, these two important concepts that we discussed, that we say that defines pervasive computing, mobility and context awareness, what are their implications? What are the implications that are brought in by these two ideas? Mobility, let's start with mobility. And mobility has three implications. First, the applications, if you remember, mobility is of two kinds. So let me, if I have to refresh your memories, mobility is of two kinds. First one is physical mobility, that is, you are taking your device from one place to another, and the other mobility is that of application mobility. That is, the application has to run on various devices. So mobility, these two mobility models combined, has three implications. One of them is, and it comes from the application mobility, that now you will have to worry about this application being run off hundreds of platforms. How would you take care of that? Some devices would have different resources to offer, the others would have not entirely different set, but there would be some difference between the resources that are available in these devices. Maybe some offers a stronger processor, some offers a little bit lower end processor, some would have high storage memory, other would offer a less storage memory. So combination of these. But you will have to worry because your application would run on this environment. So if your application is using 512K of main memory, you will have to make sure that this is the minimum that is available on all the platforms if you want your application to run on all of them. The other, of course, way is just to put a restriction that, okay, it would not run on the lower end machines and it will run on the higher end mobile devices. But if you want a cross platform and you would want to market your device as, or application as, that it will run on all the devices that are available in the market, then you will have to keep into mind that what is the minimum available in the market, and you will have to tailor your application accordingly. Second is And that aspect comes from physical mobility, that when we say that the user will move from one place to another, it would be simply going from one room to another. It can also be going from library to outdoor to the classroom. It will be going from your office to the conference hall, any type of mobility. What changes with this mobility is your context, is your environment. And from the environment, I would just refer to connectivity at the moment. That in your office, there might be a different connectivity mechanism than in the conference room. Or in the library, there will be a different connectivity mechanism than in the outdoors or in the grounds. Your application should be able to take this into account, that your connectivity may change anytime and without notice. This wouldn't be like this, that you will tell your application that, okay, now I'm moving from this place to this place, and configure yourself accordingly. It will be just that at some point your application will find out by itself, and that should be the ideal case, that it is trying to transmit some data and it is not going because you are at dead end, you don't have any connectivity. Or your application is sending some data and it is going on a slower speed. So it should detect that now your connectivity conditions are changed. The third implication came from the context awareness part. And if your application is context aware, that is, it is making some decisions based on your environment, based on its objective, it should also know that the context of application can change anytime. And that again, without any notice. When you go from one place to another, I mean, even if I change my location just few steps, my GPS location will change, my long latitude will change, and maybe there is different set of objective for the application at that long latitude than this long latitude. So the application should be able to understand that my context awareness, if it is context aware, then it should understand that my context can change anytime, and that also without notice. So these are the three implications that are brought in by mobility. The first one, the application portability, because application moves, applications are supposed to run on various platforms, and my program or my application should take into account that today if it's running on a Nokia smartphone, tomorrow it should be also able to run on BlackBerry smartphone. So I should be taking that into account. Second, my physical mobility, that will change my connectivity parameters. If at the moment I'm connected through a very strong link, maybe after 2 or 3 minutes, I will be connected to a smaller link or slower link. How would that? And third, my context can change without notice. So these are the three implications that are brought in by the mobility aspects of the pervasive computing. And we are talking in context of software development for pervasive computing. Next time, we will continue from here. We will continue thinking of how to develop software for pervasive computing. And now we have just discussed the mobility aspect. We will discuss the context awareness aspect and see what implication that brings in from the software development perspective. Till then, I hope you have enjoyed today's lecture. I am Abdul Aziz signing off. Allah Hafiz.